Hello everyone, my name is Abhishek and welcome back to my channel. So today I'm going to explain you a very advanced Kubernetes real-time project. So don't worry saying that this is an advanced Kubernetes project you might not understand. No, I'll make it as simple as possible and I'll try to explain you as much as possible. And after this video, I'll request all of you to consider this as an assignment and try it by yourself, right? So the reason why I'm telling you is most of the people comment on our YouTube videos, or people also approach me on LinkedIn, and the question that they ask is, Abhishek, I'm learning the concepts but somehow I'm not able to crack the interviews, or when the interviewer asks me about real time problems or real time projects that we are dealing with, I'm not able to answer these questions. So that is one of the reasons why I'm making this video, where if somebody asks you what is your day-to-day work, or what exactly are you doing with Kubernetes, or even what are some of the real-time projects or real-time problems that you faced with Kubernetes, so this one project can really help you. Just put this project as it is in your resume. I have the GitHub repository also. I'll share you the GitHub repository where I have written all the instructions that you can try out after this video. Let's say you did not understand some concept, or you want to go back and reference. So you all know my GitHub ID already. So just go to my GitHub account, and yeah, I'll put the link in the description as well. You don't have to worry about it. But I have just created a repository called K8s. So this is the repository. I'll put the link in the description where I have provide you the project description. So you know what exactly are we going to do today? Enforce automated K8s, which is Kubernetes cluster security, using Kyverno policy generator and Argo CD. Now there are many unknown words. I know most of you people are just learning Kubernetes, and by looking at this terminology itself, you might feel that, oh, okay, what exactly is this? I'm not able to get it. But trust me, whenever you are going to project yourself as a DevOps engineer, and whenever you want to add a project to your resume, adding such keywords will attract the interviewers, right? So when you just say that I've deployed a pod in Kubernetes, or I just deployed an application in Kubernetes, many people will do it. What is your difference, or why exactly the recruiter, or why exactly the person should hire you? Because you have done some extraordinary projects, and this is one of the extraordinary projects. I'll tell you the reason why I am stressing so much on this project and why I'm saying this is very important, because this solves some real-time problems. So whenever there is a real-time problem, there has to be a real-time solution. So this project explains about the real-time project problem that you can express to the interviewer, and you can say that, okay, when I'm working with Kubernetes, I have noticed some problem, and for this problem I have built a solution by myself. So this is the solution, and this is the exact project, right? So what exactly are we going to do today? So this definition you understood. I mean, there might be some things that you might not have understood in the definition. So I'll break it down to very simple terms. Okay. So what exactly we are going to do today is we are going to build this project. Now, again, there are many components. Don't get confused. So this is a DevOps engineer. Okay. So what DevOps engineer does in a day-to-day life is, one of the main things is to manage the Kubernetes. Apart from deploying your CI/CD pipelines, so definitely you will write CI/CD pipelines to deploy your application onto Kubernetes. But assume this is your Kubernetes cluster. Okay. So in Kubernetes cluster, you will have hundreds of namespaces. For the example, I just took 4 namespaces. But if you are a DevOps engineer in a MNC, multinational company, let's say you're working for Red Hat, Walmart, or you're working for Amazon, Flipkart. So the number of users that these applications have is humongous, right? Let's say you are using Amazon today. Parallelly, how many people in this India are accessing, or parallelly, how many people in the world are accessing Amazon? AWS, Amazon, or any of these platforms. So the number is huge. So whenever you want to scale your applications and you put these applications on Kubernetes platform, let's say, so there are hundreds of microservices. So for each microservice, let's say Amazon has payments as microservice. Amazon has transactions, login, logout. There are many microservices. So there are development teams who are dedicated to this microservices. So let's say namespace A is working for login application of Amazon. Namespace B is a project team who is working on logout application for Amazon. Namespace C is for transactions, and namespace D is for payments. Let's assume that. Okay. So as a Kubernetes administrator, what you have done is you have created 4 different namespaces. Okay, and you said that, oh, okay, so login project, work on namespace A, logout project, work on namespace B. So you have created an isolation inside your Kubernetes cluster as well, right? So now, what exactly the development team does? So the development team keeps on deploying their applications. Am I right? So for each development team, you can consider there is a CI/CD pipeline that you have built, and whenever they are running that Jenkins CI/CD pipeline, the application is getting deployed in namespace A. Similarly, for namespace B, namespace C, and namespace D as well. Now everything is going good. Now, what is the problem? Like if everything is sorted out, you followed Abhishek Viramala tutorial or you followed any other tutorials, and you said that I created a Jenkins pipeline and this pipeline is deploying the application on Kubernetes. So my end-to-end pipeline is built and my work with Kubernetes is done. Is it? No. So this is just 10% of your day-to-day activities in Kubernetes to deploy your application using the CI/CD pipeline. But the major challenge is that once you dedicate these things to your project teams, now there comes the challenges of scaling your Kubernetes cluster. Okay, sometimes people say that, oh, you just have 20 nodes, but 20 nodes is not working, scale it up to 100 nodes. This is one problem, right? But we are not talking about that problem. The problem that we are talking about today is the governance of your Kubernetes cluster. Now, if you have heard this term called as governance for the first time, don't worry about it. So the term governance is something that you have to be very familiar in DevOps terminology, because whether it is Kubernetes, whether it is AWS, Azure, the problem is same, right? You have multiple teams, multiple project teams working on different applications. And as a DevOps engineer, you are solely responsible for managing that AWS cluster or this Kubernetes cluster, right? So managing according to the compliance of organization. Okay, I'll repeat this word: managing according to the compliance of organization. Now again, what is compliance? So compliance is, in very simple English, you can consider as rules. Okay, so every organization has some particular rules. For example, there is a company called example.com. What example.com says is, oh, DevOps engineers, just make sure that nobody in our organization who has access to create EC2 instances should not create EC2 instances with more than 64 GB RAM, for example. Okay, because organization has some billing issues. So this is one compliance. Or organization defines that, okay, in a Kubernetes cluster, nobody should create a pod with latest tag. Okay, this is another sort of compliance. What happens is, if somebody creates pods with latest tag, let's say you are deploying Nginx, okay, and if you're trying to deploy Nginx with latest tag, what happens is that tomorrow the latest tag gets updated. And if you're using this Nginx in production with latest tag, for some reason your pod got killed, but replication controller or the deployment will bring up the pod, and now the Nginx has come up with the latest version of latest tag. That means yesterday there was one latest tag, today there is another latest tag. So your application has changed without your interference. So this is one example. Okay, now don't go into the details of it, but what we are trying to understand is that every organization has some rules, or every organization has some compliance. And as a DevOps engineer, you have to make sure that that compliance or that rules are met. This process is called as governance. Okay, so if you search for AWS governance, or if you search for Kubernetes governance, you'll find a lot of these terms. Okay, now don't worry about it. So this process of doing Kubernetes governance can be done using one specific tool that we are talking today, that is Kyverno. Okay, so if you see here, this is called as Kyverno. Now, why we need this tool? What is the problem statement? Always try to understand the problem statement. For example, if you want to do the governance of Kubernetes, so what Kubernetes has is something called as admission controllers. Okay, so what is the term? Admission controllers. Now, writing this admission controller is not that easy. So not everybody has knowledge of Go language, right? Let's say you want to write a new admission controller. Okay, what is this? Admission controller. What admission controller basically does in Kubernetes is it will validate, mutate the authenticated and authorized user request. That means to say, so let's say you want to do the exact same thing that I defined. That is like everybody who creates a pod in your Kubernetes cluster. Okay, let's say somebody is creating a pod in your Kubernetes cluster. So one governance rule that you have decided within your organization and within the DevOps team is that anybody who creates a pod, the condition is that their pod should have resource requests and limits set. Now, if you followed our previous videos, I already explained about resource requests and limits. That is, let's say this entire Kubernetes cluster has, for example, one of these Kubernetes cluster has a node with 50 GB RAM. But what happened is that one of the pod, and there are 100 applications deployed on it or 100 pods deployed on it, but one of the pod is leaking a lot of memory. Okay, so it itself is taking 50 GB RAM. Now, what will happen to the other 99 pods? Even the pod does not have any issues with it. Okay, so the pod was working fine. But the reason why these pods are failing is because one pod is taking 50 GB RAM and remaining 99 pods are just waiting for the resources. But this one pod which is taking 50 GB is not allowing the other 99 or other 49 pods to run. So this classic problem can be solved by allocating resource requests and limits to pod. So whenever developer or DevOps engineer creates a pod, there is a section in pod YAML specification YAML where you can say, oh, okay, my pod should only take 2 GB RAM. Okay, so if there are 25 pods on one node, you can say that each pod should take 2 GB RAM. So this is about resource requests and limits. But how do you ensure that every developer is following that standard? So there has to be a governance that DevOps engineer should be doing. What is that governance or what is that rule? Every pod that is created inside this Kubernetes cluster should have proper resource requests and limits. So this is the governance rule. But the problem statement here is how do you define this governance rules, right? So one classic way of doing it is using the admission controllers. Okay, so what is admission controller in Kubernetes? So admission controller, what does it mean? Whenever somebody is doing some admission activity, whether you are trying to create a pod, whether you are trying to do a deployment, whether you are trying to create a service, everything goes through Kube API, right? So what Kube API does is, if you create a admission controller in Kubernetes, basically a Go language controller that you write by yourself and deploy in Kubernetes, every request that goes to the Kube API will go to this admission controller that you have written, and admission controller will basically validate, oh, okay, so this resource requests and limits are there in the pod or not. Okay, so if I am a DevOps engineer for Red Hat, what I'll do is I'll write an admission controller saying that any pod that is deployed in the Kubernetes cluster should has this resource requests and limits. So this is how you can solve the problem, right? So now you will say that, oh, okay, Abhishek, if writing an admission controller can solve this problem, now why should I do this entire project that you are explaining me, right? So this is the question. But the answer is writing admission controller is not that easy. Let's say today you are DevOps engineers, but you don't have knowledge of Go language. Or let's say I am a DevOps engineer, I have good knowledge of Go language, but I cannot write so many admission controllers, right? For example, for resource requests and limits, I wrote an admission controller. Tomorrow, the organization will say that, okay, this is the new rule. Tomorrow, day after tomorrow, they'll say this is the new rule. So can I write hundreds of admission controllers? People used to do that. People used to write multiple admission controllers. But now the classic problem is that writing so many admission controllers will take so much of DevOps engineers' time. And tomorrow you might modify this admission controller rule. Okay, tomorrow organization will say, oh, no, scrap that rule. We don't want that rule. So the problem is that DevOps engineer spends a lot of time in writing this admission controllers, changing the behavior of admission controllers to governance or to govern your Kubernetes cluster. So is it clear? What is the problem statement? So the problem statement is that as a DevOps engineer, one of your classic responsibility is to do governance of your Kubernetes cluster. What is governance? Governance is nothing but maintaining or verifying or checking that your applications or your pods that are deployed or any resources that are deployed in Kubernetes are following the standards of your organization, right? So this is governance. Now, how DevOps engineers used to do this governance? They used to write admission controllers, right? But what is the problem? Writing admission controllers is not that easy. Every time you have to write an admission controller for every simple task, and tomorrow the rules are getting changed, or you want to scrap up few admission controllers. So it's a huge effort for DevOps engineer. And for small companies or small startups, this is still fine. But when we talk about huge organizations where they have hundreds of projects, thousands, millions, there are like millions of users and you have 10,000s of applications. How do you write this governance rules, or how do you even write these many number of admission controllers, and how do you give this knowledge to all the DevOps engineer in your organization? So this is a very classic problem. Do you understand the magnitude of the problem? So now, who is solving this problem? So to solve this problem, there is a tool called Kyverno. Okay, now I hope that I have set you the background of what is the problem and why we want to learn about Kyverno. So if you look at the project that I'm going to explain, I just started with explaining you the problem statement, but there is more to it. Like, there is not just Kyverno, but we are going to integrate Kyverno with Argo CD, and I am going to explain you guys how to automate this process, right? So manually you can do the governance of your Kubernetes cluster using Kyverno, where you can simplify the process. Instead of writing admission controllers, what you will do is you will just write Kyverno custom resources. That is, you will just write some YAML files that Kyverno will understand, and Kyverno will automatically create this dynamic admission controller with some webhook configuration for you. Okay, so Kyverno is a dynamic admission controller which is solving this problem of DevOps engineer writing hundreds of admission controllers, where Kyverno will say, no, you don't have to write anything. Just give me one YAML file with what you want. Like, let's say your organization says that I want pods to be created with resource requests and limits. Now Kyverno will tell you that, okay, just give me that in the YAML file, the format that I will understand. I'll explain you how Kyverno understands. So Kyverno will take this request. It will say that, oh, okay, I'm a dynamic admission controller, not like just the usual admission controller that DevOps engineers are writing. It is a dynamic admission controller where it can read your request and it can create the webhook configurations accordingly. But again, this is all a manual process. So whenever an organization is telling you that, oh, okay, let me change the rules that we have in organization and let us modify it slightly. Now again, DevOps engineer has to go to that YAML file. He has to again deploy in the Kubernetes cluster. So I'll also explain you how to automate this using Argo CD. Okay, so if you feel this is complicated and let's say you don't have proper experience with Kubernetes, so for your interviewer, even if you explain the manual process that you're doing, and you can tell them that instead of admission controllers, we have used a dynamic admission controller which can governance our Kubernetes cluster, that is Kyverno. And I have set up Kyverno in my organization and I've explained my organization the benefits of Kyverno. Even this is fine. But if you want to go to one more level and you want to say that we have achieved even more than this, then you can bring Argo CD into your picture. Okay, now let us go to this project called Kyverno and let me show you what exactly it is. Like, you don't even have to follow that. I can explain you from here as well. The GitHub document that I've created, where I have created with very good examples. Like, I've put you all the design documents. I've put all the diagrams that are required. So you can just read through the description and you'll understand everything as well. But what is important for you guys is to understand this first 10 lines, because this 10 lines is something that you are going to explain as your project to your interviewer, right? Whenever you are going for an interview, so the interviewer, first of all, directly do not ask you about the high level diagram. First of all, what he'll ask you is, okay, tell me what is the project that you are currently working on, or tell me one Kubernetes problem that you have solved. So what you will say, you'll start with, we have done a project which will enforce automated or manual Kubernetes cluster security using Kyverno policy generator and Argo CD. If you don't want Argo CD, you can remove that as well. Now, what do you do in this project, or explain what is this project? Interviewer will ask you. Then you will say that as part of this project, what I have done is I have enforced some policies to governance or to maintain the organization according to the compliance that we have for your Kubernetes cluster. Now the Kubernetes cluster can be on AWS, it can be on Azure, it can be on Google Cloud Platform, or it can be on-premise Kubernetes cluster. The process is same. Let me tell you with an example. So you can say the same thing to your interviewer. Tell the interviewer that, okay, let me explain you with an example. To explain you with an example. We have a requirement that every pod that is created in a Kubernetes cluster should have resource requests and limits. So this was a classic problem. Initially, we have written admission controllers to solve these problems, but as the team keeps growing, as the organization keeps growing, we are finding it very difficult to write these many number of admission controllers. And because the behavior is dynamically changing, the organization is just building up and we have new compliance rules, the existing compliance rules are modifying. So we thought, let us use a tool like Kyverno, which is a dynamic admission controller. All that we need to do is, instead of writing admission controllers, we will just write some YAML files that Kyverno will understand, and Kyverno will write the required webhook configuration for us. Okay, so this is how you explain about the project. Now, what Kyverno can do is, Kyverno can do 4 important things for you. One is generate, second is validate, third is mutate, and fourth is verify images. But first of all, do not learn about all of these 4 topics. You will get confused. Let us only start with validate. Okay, so it doesn't matter if you tell your interviewer that you have worked on all of these 4 functionalities or not, because your interviewer will only be keen about something that you have done exceptionally well. So tell them that with Kyverno, we have implemented the validate functionality where we can block users. Okay, if the standard or if the pod is not matching the standard that we have for our organization, whether it can be resource requests or whether it can be some labels or whether it can be the pod security policy, if any of these things is not matching, we will not allow the pod to be deployed on the cluster, and we will block the deployment, saying that it is not matching the standard of Kyverno, or it is not matching the standard that we have for our organization, right? So this is the thing that you have to explain, and this is the high level design diagram, the one that I am explaining you till now, right? So if you click on it, this is the high level design that we have done. Now, what is this high level design and what is the scope of the DevOps engineer in this? So as a DevOps engineer, you will write a Kyverno policy. Now, I have been telling you about writing Kyverno policy, but how difficult is this? Let me show you the example of the Kyverno policy that we have been talking about. That is restricting pods without resource requests and limits. Okay, so this is the example that Kyverno has provided us. You can go to this GitHub repository. I'll show you the link of this as well, or I can directly put these examples in my repository as well. So this is the Kyverno custom resource, or this is the Kyverno policy that you are going to write as a DevOps engineer. Now, these annotations you can ignore for a while, okay? Because annotations are just for explaining somebody who's reading this YAML file, just to explain them that what you are doing with this policy. But the spec is important. All that you need to do is, instead of writing admission controllers, you just need to learn about this spec. Okay, so if you can write this spec, that is equivalent to writing admission controllers, because Kyverno is a dynamic admission controller that is reading the spec and it is doing the job for you. So as a DevOps engineer, now you don't have to learn how to write admission controllers. If you know the concept, it is very well and good. As I always tell you, if you know programming, if you know how to write applications in Python or Go language, it is definitely an advantage. But not all DevOps engineers have this knowledge. So you can assume that if you can write this spec according to the way that Kyverno understands, then it is as good as you writing a dynamic admission controller. Okay, so what is in the spec and how difficult is writing the spec? So again, don't worry, I have explained very well in the document, which I'm going to show you right now. So the spec can be divided into 2 parts. Okay, one is the policy and one is the rule. Okay, so if you see here, the example that Kyverno is providing, it will have the same thing. Okay, so here, sorry for that. So if I go back to my example, where is this? Yeah, so it has a rule which has the match exclude, like which resource this rule has to match. Does it has to match a pod? Does it has to match a namespace, or does it has to match a deployment? So that is exactly what is defined in this example. Okay, so if you see here, it says the rules, inside rules, I just provided the match. Which resource it has to match? Pod. Okay, so this is about the rules match, right? The same thing that we have in the diagram. So rules match. After this, I'll explain. Yeah. So after the rules match, I have the condition. Here, what I'm doing is I am validating. That means to say, I am saying whether this request that I am going to say, should it block the users, or, I'm just validating if the resource that I'm creating has the required conditions or not. Okay. So if you see here, what I'm saying is the rules has to match the pod. Now, what are the rules? So these are the rules. The rules are inside the pod spec, inside the containers, there should be resource requests and limits set for the pod, right? So now tomorrow you have to modify this example. Let's say I want to modify this example and say that pod should have pod security policy, or for easy example, let's say pod should have a specific label. The label should be just app is equals to some xyz. So what you will do is simply you will have the same resource just inside this pattern. Instead of spec, what you will say is metadata labels. You should have a specific set of labels. If it has to be tomorrow, the container name should be in a specific matching pattern. You'll say inside containers name, the name should be of a specific pattern. So all that you will modify is these things. Okay, so if it is a pod, you will have the same way, and the only thing that modifies is inside the container, you will just modify these fields. So it is hardly about writing the Kyverno YAML files, and it will take not less than 1 hour in learning these things. For example, Kyverno itself, in this specific repository, you can find the repository link in the description as well. So Kyverno policies has a lot of examples. Okay, let us take one easy resource for our understanding. So I think all of us will understand about namespace. Okay, so what this Kyverno resource is saying that add namespace quota. Okay, so what is this resource? Let's try to understand. Here it is saying this is the Kyverno policy, add namespace quota. So similar to the pod resource quota, what Kyverno is saying here is that every namespace should has a specific resource requests and limits. Like similar to pod, namespace can also have a resource and request, right? Because if there are 10 namespaces in your organization, only one namespace cannot eat all the resources of your Kubernetes cluster. The same problem, only one pod cannot eat all the resource and requests, because all the other pods will die. Similarly, if one namespace is eating all of your resource and requests, all the other projects or all the other namespaces will die, because they will not get the similar resource and requests. So what you are doing is you are defining a resource called resource quota, and in the resource quota you are saying this field should be there. Okay, so Kyverno policies, all that you need to modify is the inside the validate functionality and what is the type of resource. If you take one more example for your understanding, so after this class I want everybody to go through these examples and understand. Okay, because once you understand these examples, it's just like a cakewalk. Now I'll also deploy these things and I'll show you. Don't worry about it. Firstly, let's start with installing these things. Okay, for the very first thing, what all of you guys should have is a Kubernetes cluster. Okay, so I'm not going into details of explaining you how to install a Kubernetes cluster or how to deploy a Kubernetes cluster, because we have already done it. Like if you have not watched our previous video, you can just search for Minikube on our channel and you will see that I explained you how to create a Kubernetes cluster. I explained with K3s, I explained with K3D, kind, and also Minikube. So whatever you want, you can use it. In my case, I just have a local Kubernetes cluster already with me, and I'll just open the document that I have prepared for you guys, the GitHub repository, and I'll just follow the instructions, because that way I can also validate that everything I created in the document is working as expected. Okay, so I've opened the document in a different tab, and let us see if my Kubernetes is running or not. I'll just say kubectl version. You'll see that my Kubernetes cluster is running. I can also say kubectl get pods to just verify if everything is working fine, right? So no resources found. That means that Kubernetes is created as well as the kubectl is configured with that specific namespace. Okay, so firstly, let's install Kyverno. So to install Kyverno, you can just follow my document. What you can do is you can just open the GitHub link that I have provided, like this one here. I'm just referring to the document, and there are two ways to install Kyverno. One is you can install using Helm charts, or you can directly install Kyverno using the manifest files. Okay, so in my case, what I'll do is I'll just install using the manifest file. So this is the kubectl create command using which you can create a Kyverno. Okay, so this is present in the GitHub link. You can just copy it from the GitHub link. So now Kyverno is already installed. After this, what I'll do is I'll install Argo CD. Okay, so if you don't want to install Argo CD, if you don't want to go to the advanced project level, you can simply skip Argo CD, because even with Kyverno, your project will look so good and your interviewer will definitely be impressed with you. Okay, so just for keeping everything in line, I'm also installing Argo CD. Okay. So all the resources are getting created for Argo CD. Previously, all the resources got created for Kyverno. Now we have both Argo CD and Kyverno installed. Now I'll start with a very basic example, the same example that I told you guys. That is, I'll just create a Kyverno policy for the pod requests and limits. Okay, so how I'll do that? I'll just open this GitHub link. Okay, so the GitHub link is also present for you guys in the description. You can follow the GitHub link as is. So this is the Kyverno resource. It is present in the Kyverno policies repository. I'm just copying it. I'll just open this link in the raw file YAML, and I'll just copy this link. And what I'll do is I'll go back to my Kubernetes cluster here, and I'll just execute this command. Okay, so now you will see what happens is okay, kubectl. How do I do that? Kubectl apply -f followed by the, there is a typo here, sorry. So kubectl apply -f followed by the location of the file. Now it will install the, what happens after this workflow. Now as soon as I deploy it, what I am doing, I am, as a DevOps engineer on my Kubernetes cluster, I created a Kyverno policy. Okay, now this Kyverno policy, instead of storing in the Git, what I did is I directly deployed onto the cluster, because I just want to skip this Git and Argo CD part, because firstly I want to show you the manual way of doing it. I don't want to put this Kyverno policy in GitHub, from there pick from Argo CD. Initially I will show you manually, later point of time we can automate with Argo CD. So here what I did is I jumped directly from here to here, and I installed the Kyverno policy directly on the Kubernetes cluster. Now who is reading this Kyverno policy that you have created? This Kyverno Kubernetes admission controller. You can go to your this thing and just say kubectl get pods. Okay, you will see that there is a Kyverno pod that is running. Just grep sorry, what I need to do is I have to search for all namespaces, because Kyverno basically gets created in its own namespace. Okay, so if you see that Kyverno is a pod that is running on the Kyverno namespace, because the reason why you create namespace separately for Kyverno, or even for that matter of fact, whenever you're installing any applications like Argo CD or something, create those applications or that controllers in their own namespace, so that you know whoever let's say you are a DevOps engineer team and you want to manage the Kyverno, you can just say that all the resources for Kyverno is present in the Kyverno namespace, and even for your metrics or even for your analysis, it gets very easy if you have a dedicated namespace for the controllers. Now Kyverno is running. So what is happening behind the hood is you have installed the Kyverno policy, and this is a Kyverno controller that is sitting inside the cluster. It reads the policy. Okay, even if you try to look into the logs. Okay, let me go back here and show you kubectl logs. What I'm trying to search for the logs? The Kyverno -n Kyverno. Okay, so if you look into the logs, you will see that, see, this is the same this is the same YAML file that I have deployed, and Kyverno controller has read the YAML file. Okay, if you have any doubts, you can just search for this one here, and what you will do is you can go back to the example that I'm showing you, this one here, and you can just search for this one here. So the name is require resource request and limits. Sorry. So here, if you see, the name of the cluster policy that we have deployed is require request and limits. Now who read this one? So here, if you are looking into the logs, require request and limits is read by the Kyverno controller. So this is how you will explain the interviewer. What you will explain the interviewer, that I have created a Kyverno policy directly onto the cluster, or I put that in the GitHub repository and automated using Argo CD. You can say anything. Now, once the Kyverno policy is deployed on the cluster, there is a Kyverno Kubernetes admission controller. That is a That is a dynamic Kyverno admission controller, which is reading your policy and according to the definition that you have created. So what you have created in your Kyverno policy, you said that every pod has to be created with requests and limits. Now you have also defined which namespace, right? So if we go back to the example, sorry, where is that? So if you go back to the example and if I show you this file, so here you have defined that this is a cluster level policy. So you are asking your Kyverno basically to monitor in all the namespaces of the cluster. So in our example, if we have 4 namespaces, okay. So in our example, if we have 4 namespaces, then you are telling Kyverno that in all of these 4 namespaces, if you create a pod, that pod should have resource requests and limits. If that is not the case, simply block the creation of the pod. Okay, so this is what you are telling Kyverno. Now let us see if Kyverno will be able to do it or not. Okay, so what I'll do is I'll just say kubectl create deploy nginx. Okay, so okay, what I'm trying to do here is I'm just trying to create a deployment. Okay, a very basic deployment where using this deployment, I'll show you how to, like, I'm not using the Kubernetes YAML manifest, or I'm not using any of these things. Instead, using the kubectl command line itself, what I'll do is I'll just create a deployment. Okay, and this deployment will indeed create a pod, right? So let us see if the pod request is blocked by the Kyverno or not. So by default, this pod request has to be blocked because we are not creating this pod with any resource requests or limits. You understood this, right? So now we are going to validate if Kyverno is working as expected or not. So for that, kubectl create deployment nginx -fn image is equals to nginx. Now, as soon as I click on enter, so the deployment got created. Perfect. Now let us see if the pod is getting created or not. kubectl get pods pipe grep nginx. Okay, so let us see if the pod getting created or not. So still now, till now, it is just saying that the container is in creating stage. Let us wait for it. Okay, so container creating, it will take some time because I am using my local Kubernetes cluster, but the end result will be that the Kyverno will be blocking this nginx request. Okay, even in the Kyverno logs, like the previous logs that I showed you, you will clearly see that Kyverno has blocked the creation of the pod because it did not meet the standard. Okay, so if I once more show you the log, so see here, it is trying to validate. Okay, performing some background scan. Why is it performing some background scan? Because there is some resource that is getting created. Okay, so Kyverno will continuously do this background scanning. So you will see that the nginx pod will never get created. Okay, so this is one major thing about Kyverno. Now, why this nginx pod will not get created? Because your DevOps engineer has configured some rules. Okay, the rules that are configured here saying that no pod should be created without resource requests and limits. Okay, and you can also in the Kyverno example itself, the example that I showed you guys, what you can do is inside this here, what we are doing is we are using this pod requests and limits. So here you can also leave message for your users. So whoever is creating this, you can say that, using this entire annotation, the annotation called policies kyverno.io description, you can define why this pod is failing, because the user should understand, right? Whenever the pod is failing, the user should understand what is the reason, why is this pod failing. Okay, so for that reason, what you can do is you can simply say, okay, I'll just explain why the pod got created. Don't worry about it. There is a reason why it got created, and I'll show you how to enforce that action as well. So here you can basically define what is the reason why your pod is getting created or failed. So this example that I've taken, what they have done is they said that validate failure action. That is, should I fail the action or not? Here they have something called as audit. So actually it should be enforce. Okay, so for that reason, what happened is the pod got created, but in the Kyverno logs or in the metrics of your Kubernetes or your alerts, you will get recorded that one of your application is not going in accordance with the compliance. So how do I change this behavior in the Kyverno? So I have created a pod definition, right? So I'll just say that kubectl edit So let us edit this resource, and instead of the action, what we will do is we will, here the action is audit. So what I'll do is, instead of audit action, I'll just modify this action as enforce. So if you modify this action as enforce, or even if you don't put any of these things, so the default action will block the resource. Okay, what is the name of it? Require resource request. Okay, so as you open this one, what I'll simply do is I'll just go down, and here, yes, instead of audit, let us simply change it to enforce. Okay, so you can find the same thing in the documentation as well. Even if you go here, if you just search in the Kyverno documentation, not this one here. Yeah, so this is the Kyverno documentation, and if you just search for enforce here, you will directly understand, okay, what is Abhishek talking about, why you have to basically, enforce the actions, or why you have to. Sometimes what happens is, in some cases, you do not want to enforce, but you just want to record the action. Okay, so in such cases, you can directly say audit. So audit means it will go to your auditing logs. Now the resource is edited. So let me delete the Nginx deployment, whatever I have created. kubectl delete deploy Nginx. What happened today? Yeah, so if I say kubectl delete deploy Nginx, now this deployment got deleted. Now let me enforce this action. Okay, so to enforce this action, I have modified it in the Kyverno. Now, even if you look into the Kyverno logs, you will see the change in the behavior. It will say that, yeah, see here, updating the policy. Why it got updated? Because I just modified. Now, let me create this Nginx one more time. kubectl create deployment Nginx. Now in this case, see what happened? Kyverno blocked your request. Okay, so as soon as I enter the comment, Kyverno told us, no, 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 there is a admission controller, this admission webhook that is created by Kyverno. Okay, because Kyverno is a dynamic admission controller, so it created an admission webhook, and using this admission webhook, the request got denied. Okay, if I remove this one again, let me show you with the example. So let us delete the Kyverno policy, kubectl get cluster policy. Okay, so this is the cluster policy that we have. I'll delete this Kyverno cluster policy, delete cluster policy, followed by this. Now immediately this will get recorded in the Kyverno logs. Okay, so you'll see that inside Kyverno logs, you see that the policy got deleted. Now let me try to install Nginx, and this time it has to get installed successfully. Okay, so kubectl create deployment Nginx -Nginx deployment dot created. So this is the difference, guys. So this is how you enforce the governance rules, or this is how you do security. You configure the security for your organization using Kyverno. Got it? So understood how Kyverno works and understood how you have to governance your organization. So there are bunch of examples, and I want you guys to basically start with a very simple example. Okay, so I'll share you the repository, don't worry about it, where we have tens of examples. So here I just explained you about one example, that is required pod request limits. Okay, but what you can do is you can start with other example as well. Like you can start with add namespace quota, or you can start with, okay, basically just start with require, the ones that are in the require state here, because like I told you, we'll only target the validate functionality of Kyverno, and all of these things that starts with require dot all, require labels, and I'll also try to add more and more examples to my GitHub repository here. Okay, so this GitHub repository right now do not have any examples, but as soon as I close this meeting, I'll just start adding bunch of examples where you can use the same examples and you can try it out by yourself. So all that you people should do is start with your Kyverno. Start with your Kubernetes cluster. Once you have the Kubernetes cluster, just follow the document, understand the high level design diagram. Once you understand the high level design diagram, install Kyverno. Either you can install using Helm charts, or you can install using manual mode that I've explained you using the Kubernetes manifest YAML files, this example, this command. And then if you want Argo CD, just install the Argo CD. If you don't want Argo CD, you can ignore Argo CD and go with the manual installation as well. Okay, then understand how Kyverno policies and rules are written. Then immediately what you will do is you will just follow the example that I created. Okay, so either you can go with this repository, or immediately what I'll do, okay, let me do it right away. Okay, so that whoever is following this video, they should not get they should not waste their time. So that's why I'll just copy this one here, and let us put this Kyverno example in my repository. Okay, what I'll do is I'll create a new file in a folder called examples that you people can play around with. Oh, sorry. Uh, I added the entire thing to the name. Okay, so go to the file, sorry, add file here, create new file. Here just say examples slash pod request limits. I'll say enforce. Okay, enforce pod request limits dot YML. Okay, I'll just copy this one, and what I'll do is validate failure action should be enforce. If the validate failure request action is only enforced, then only you will see that error directly on your screen. Else you have to go to the alerts and see what is happening. Okay, but I want to make this thing very easy for you guys because you are just starting with Kyverno and you are just starting with Argo CD. So firstly start with the validate failure action as enforce. Now let me commit this file so that anybody can use this example.